Yeah, so we are almost done with the chapter. So a quick recap of what we derived in this lesson. In this section, we had the number density of electrons between energy levels E1 and E2 is given by integral E1 to E2 G of E F of E dE. F of E we saw in an earlier lecture. This is the expression. G of E is what we derived in today's section. And the last thing we're going to see is a graphical representation of that. So we'll look at f of E first. F of E at 0 Kelvin, what was the definition we studied? Fermi level is the highest occupied level. Any level below Fermi is occupied with probability 1. Any level above Fermi is not occupied, probability of occupation 0. So at 0 Kelvin, if you see, up to the Fermi level, probability of occupation is 1. After Fermi level, probability of occupation is 0. And at the Fermi level itself, it's a dotted line, meaning the probability of occupation is not defined. This is what we had studied. And for any other temperature greater than 0 Kelvin, the definition we learnt was Fermi level is that level where probability of occupation is 0.5. So you can see this is roughly 0.5 and Fermi level has occupation 0.5. So as the temperature rises, this part becomes a little less than 1 and this part becomes a little more than 0. It was initially 0, right, at 0 Kelvin. So now a small non-zero part comes into play. This is for your f of E. For the g of E function, it is just, if you see, it will be g of E versus E. The relationship is g of E is directly proportional to E raised to 1 by 2. So you have this kind of a graph. And your number density is g of E times f of E. So the graph will be the product of these two graphs and this is what it looks like. So with that we come to the end of quantum mechanics.